Good morning, this is Ms. Billerbeck, and we're going to talk about adding and subtracting fractions. Let's start with trying to understand, well, what are fractions? So let's look at 58 divided by 5. So let's assume that these are 50, these are all tens. Okay, so we have 5 tens. And then we have 8. So these are my ones. So okay, there's my 8. So I have 58. And I want to divide this into 5 piles. So that's kind of easy. I have 1, 2, 3, 4, 5. And then I'm going to distribute some of these to each pile. But oh, I have 3. What am I going to do? I have 3. I don't have a way to break these up. So what I'm going to have to do is find a way to break them up so I can split them into 5. So I have this, and this, whoops. So I'm going to make little ones. These are a little harder to work with than I thought. Let's see if I can get them to get under control there. 2 there, and we have one more row. There we go. Okay, so if I take these ones, okay, so I have my ones, and I make them into 5 sections. So now I know these 3 ones are the same thing as those red tiles. So now I have, if these are fifths, so if this is 1, and this is broken into 5, then these are 1/5. So each tile's 1/5. So now I need to count, well, how many fifths do I have? I have 5 times 3, which is 15. So there's 15 fifths. And we might say, wait a second, 15 divided by 5 is 3. Well, that's what we had. We had 3. So we were trying to divide all these up so we could break them into the other 5. So we broke them up into 15 parts to do that. Okay, so now as 15 fifths, we can divvy up these a little bit better. So we see that we have 5 rows. 1, 2, 3, 4, 5. Ah, that makes it easy. We could take 3 here, 3 here, 3 there, and 3 there. And also 3 here. So look at that. All 5 of my groups are the same now. So each group is 10 plus 1. So let's write that down. Each group is 10 plus my 1 plus 3 fifths, which is 11 3 fifths. All right, well, is there a different way to do this besides have these manipulatives that we may or may not have? Yes, there is. So if we take the dividend, 58, and we put it in the house. So we have 58. It's first come, first serve on this house, okay? So 58 is the first one. It goes in the house. It's being divided by 5. So we know that there's 1, 5, and 5, and we multiply 1 times 5 here. So we have 5, we subtract, and we get 0, and we drop the 8 down. And we also know that there's 1, 5, and 8. So we subtract. That's 1 times 5 again, and we get 3. But we're finished with the number, And we're not doing decimals, we're just doing fractions. So we have a 3 remaining, and we have a divisor there. So what we're going to do is put the 3 over the 5. So we put the remainder over the divisor. And look at that, 11 3/5, 11 3/5. Voila, we did it. All right, so let's look at a different problem. So we have example 2. So this time I have 4 divided by 5. Okay, so I have 4 things, and I'm going to divide it by 5. Okay, so remember that these 5s, these 1s are represented by 5 of these. Okay, so we are going to take that, and we're going to get 4 of those. See if I can do that fast. That would be quite something, huh? Okay, let's get these there. All right, so let's make this up. So we have 1, 2, 3, another one. Okay, so I have 3. I need 1 more set of 5 to do this. Okay, so I've created 4 1s in red. Okay, so I have 4, and now I'm about to divide it by 5. But we see we have 1, 2, 3, 4, 5. So we have 4 divided by 5 would be, and remember, these little guys are fifths. So we have 1, 2, 3, 4 fifths. Okay, so what if we did this with long division? Aha, this is where we might make a mistake. We might forget first come, first serve, and this is a 4 that is first. So we put 4 in here, and we don't need much of a house because we're doing fractions. And the 5 is out in the rain. So we ask how many 5s are in 4? None. There are no 5s in 4. And we subtract, and we get a remainder of 4. So we write that as 4 over the divisor 5. So this is always the remainder over the divisor. Okay. All right. Well, let's look at a different problem now. And I will just take my little fists and put them over here. Okay. All right. What if I have fractions now that I'm actually going to try to add, and they don't have the same name. The name is the denominator. Okay, that's denominator. Denominator. So we don't want to say denominator, it's denominator. Okay, and denominator is a name. It's like denomination is for money. What denomination are we buying this in? Are we buying it in English pounds, or in yen, or in dollars? What denomination are we buying this in? So that's what this is. So this denomination is a 3. And this denomination is a 2. They are not like. So this represents, if this is 1, and I've broken up the 1 in 3 sections, that's 1/3. And this is 1, but this is only half. So I've drawn it out 1/3 plus a half. And we can see, well, I can't just put it over here because I don't have the right denomination to move this half right over here. So what I'm going to have to do is change the denomination or denominator to a different name so they can have the same name. Once they have the same name, we can compare them. But we can't right now because they have different names. It's like comparing apples to oranges. Okay? Or comparing squirrels to fishes. Fish. Sorry, fish is plural. Okay, squirrels to fish. Okay, so we have to have the right name. Okay, so what I can do is I can see, oh, I can break that line up into 2. So this is the same thing as 1/3 because I have 2, 2, 2. So that's 1/3. And this is 3 of those. So 3, 3. So that's 1/2. So now I have the same name. But these names are 1, 2, 3, 4, 5, 6. So the name is a 6. So we're talking about 6. Okay, we've broken up into 6. So now I can take 2 of these 6 and put it right here, and 3 of these 6 and put it right here, and I can count 1, 2, 3, 4, 5, and I have 5, 6 when I add them together. So what we've learned before is that we take the 1/3, excuse me, we take the 1/3 and we add the 1/2 and we find the least common denominator so that we can name it efficiently, okay? So the least common denominator, when we can't figure it out, the easiest way is just to multiply this one by that and that one by that. So we're going to put a 2 over 2. You might say, wait a second, Miss Billerbeck, why are you just messing with that problem? Well, what is 2 over 2? It is 1. So now I'm going to put 3 over 3 here. And 3 over 3 is also 1. So I haven't changed the equation. I haven't just made it into whatever I want. I haven't changed the equation. I'm just changing the name of the denominator so that they can be compared. So now I multiply 1 times 2, and I get 2, and 3 times 2, which is 6. And now 1 times 3, which is 3, and 2 times 3 is 6. Look, they have the same name on the bottom now. I'm comparing squirrels to squirrels and not squirrels to fish. So now I compare, I have 2 plus 3, 6. So I add 2 plus 3 is 5. And then I have 6. And look, it's exactly what we came up with before. Isn't that cool? So that's why we do it this way, because it's not too easy to draw these beautiful drawings as much as they are beautiful and depictive, and they give tons of information. It's just not practical to always do our fractions in pictures. All right, but here's some more pictures for you. Okay, so anyway, let's look at 3/4. Okay, so now I've got a 1. That's all this. This is all 1, okay? So I broke the 1 up into 4s. 1, 2, 3, 4. And then I just drew in 3 of the 4s. Okay, so the The denomination for this is 4, the fourths, and I have 3 of those fourths. Now I'm going to subtract 1/3. So if I take the 1 and I cut it up into 3 equal sections, I have each one of these at the third. So that's the denomination of this one. So this one is in fourths, and this one's in thirds. Okay, so they're obviously not the same name. Okay, so I have 3/4, 1/3. I'm subtracting. I have to have the same name. So the common name for both of these, where all the lines will fit, would be 12ths. So I see that, oh, okay, so my 3/4 will fit with 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths. Okay, so 9 12ths is 3/4. And then I have my 1/3 is 1, 2, 3, 4 12ths. Okay, so now I'm going to subtract my 4 12ths from this. So I put the 4 12ths up here so I could just take that away. Okay, so then I ended up with the remaining were the 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So I ended up with 5 12ths. Okay, so let's see what that looks like with the fractions. So if I take 3/4 minus 1/3, I multiply this by 3/3, which is just 1, and this one by 4/4, which is just 1. That becomes 9 12ths, well, we counted right here, minus 4 12ths, which is what we counted right here. So when we subtract, 9 minus 4 is 5 12ths, which is what we got when we just counted what was left, 5 12ths. All right, let's move to something a little more complicated now. Mixed fractions. Oh, joy. Okay, so mixed fractions. So we have 1 1/2 and 1 2/3. Now, when I write this out in the quiz format using our online Google quiz, 1 1/2 is going to look like this. So that's not 1 minus 1/2, that's 1 1/2. Because sometimes people put little hyphens there saying that that goes together, and then plus 1, and then you put a little hyphen, 2/3. It's usually not a full hyphen, it's just like a little teeny hyphen, but you know, the keyboard doesn't have that little teeny hyphen on it, okay? So you just have to know that when I have the fractions like that on the quiz, it's going to have a little teeny hyphen like that, meaning that that goes together. So this is 1 1/2. So I have a 1 here, and then half of that 1 is right there. And this is 1, and then I broke up the 1 into 3 equal parts. So let me do that so you see that there's 3 equal parts. Okay, so 1, 2, 3. So I broke it into thirds. And this one's in halves. I guess that's hard to, so halves. I'll write it out. Halves is one of those weird words. Okay, halves. Okay, so then I'm adding this together. So I have a full 1 here and a full 1 here. So those are easy. You just put them right like that. Okay, so then I took the half and I put it here. And then I took the 2/3. But before I did that, I changed the denomination. Okay, so when I did that, I broke these up into a different denomination. So instead of halves and thirds, I broke them up into sixths. Okay, so 1, 2, 3, 4, 5, 6. So 3/6 is half, and 4/6 is 2/3. So now I can add those together. Now, if I put them, really add them together, and I put the 4 on top of this, we have 1 that's, above, one little 6 is above the rest of them. So I have to put the one little 6 down here. Okay, so now I have 1 plus 1 plus 1 plus 1/6. Well, that's just 3 and 1/6. All right, well, let's see what that might look like using our other math. So if we take 1 and we break apart 1 1/2 and say 1 plus 1/2 plus 1 plus 2/3, because that's kind of what we did with this drawing. We took the 1 and we added a half, and 1 and added 2/3. So now with the commutative property of addition, meaning I can move things around, I can say 1 plus 1 plus 1/2 plus 1/3, and then I need to change their names because 2 is a different name than, or the half is different than a third. So let's do our little trick here, 3/3 and 2/2. So 1 plus 1 is 2, and then I have plus 3/6 plus 2/6, and that gives me 2. I got 3/6, and oh, there was a 2 there. That would have been a big mistake. Okay, there we go. That makes sense. Okay, so I have 2 plus 7/6. But wait a second, that's not a proper fraction. So how many 6's are in 7? Well, there's 1 6 in 7 with 1 left over. So we have 1 plus 1/6 is the same thing as 7/6. If we didn't see that, we can put the top dog in the house. So we're going to put the 7 here and the 6 on the outside. We have 1, 6, and 7. We subtract, and we have 1 there. So we write the remainder over the divisor. 1 and 1/6. So 1 and 1/6. So now our final answer is 2 plus 1 is 3 plus 1/6. So we have 3 and 1/6. So that's how we add well, they're not improper fractions. So we add fractions with whole numbers and fractions. Mixed numbers. There we go. That's what they're called. Mixed numbers. Okay. So now we're going to subtract mixed numbers. Yikes. Okay. So I have 2 and 1/3. So here's my 2, and then I took a 1 and I broke it in 3 equal parts. So I have thirds. So this is thirds. We didn't know how to spell it. I will spell it. That's a third. Okay, and then I'm subtracting 1 and 3/4. So I have 1, and then I broke this into 3 equal parts. So this is fourths. Oops, I think I spelled it wrong. I spelled it who goes fourth instead of fourths. There we go. That's fourths. All right, so we have thirds and fourths. Okay, well, that's hardly the same name, don't you think? So we have to get the same name. So I think 12s might be the better name for them. So let's do that, 12s. I think that's how you spell 12s. You'll have to forgive me if I'm not right. Okay, so we have 1, 2, and I'm subtracting that one. And I just took that one and subtracted that one right away. Because that's easy, don't you think? Just taking 2 minus 1 and just dealing with 1. So now I have a 1, and then I have this third, and I broke it up into 12s. So even though this is still a third, it's broken up into 4 12s. Well, 4 12s is 1/3. And this 1 is 12 over 12s. And now I'm subtracting only this section because this section and one of these sections canceled out already. So now I'm taking this section and renaming it in 12s. So instead of a third here, I've got a third, 2/3, or I've got a fourth, 2/4, and 3/4. Yes, there is 3/4. So every 3 is a fourth. Isn't that confusing? Every 3 is a fourth when you're talking about 12s. Okay, so now I have to subtract this from this. Well, the easiest thing to do is just to take it straight across and take it straight across and forget about these little 4 ones. Let's just store them right here. We're just going to take this first column and subtract this from the first column, leaving these 3 and these 4 right here. And now we'll add them together, the 3 to the 4, and we see we have 1, 2, 3, 4, 5, 6, 7. Okay, so let's count that again. 1, 2, 3, 4, 5, 6, 7. So we have 7 12s. Okay, let's see if that worked. All right, so we have 2 plus 1/3 minus 1, but I can't add 3/4 because it's really minus 1 plus 3/4. So I have to distribute that negative to both of these. So this is going to be 2 plus 1/3 minus 1 minus 3/4. Okay, so now I have 2 minus 1 plus 1/3 minus 3/4, and I changed the name so I can compare them. So 2 minus 1, well, that just is 1, which is what we saw here. We just have 1 here. And then I have plus 4 12s minus 9 12s. And then I say, uh-oh, I need to do something about this. This 1 is going to have to change its denomination too. So I'm going to have to multiply by 12 over 12, which is just 1 as well. So now I have 16 12s minus 9 12s, which is 7 12s. And that's exactly what we got, 7 12s. And that's it for my recording. Have a wonderful day. Bye-bye.